Okay, it is 7 minutes past. I'm just gonna go start. Welcome. Welcome to this second to last episode of Learn Web3 with Colony. We are building a dApp and we are doing some exciting part today. We want to solve the problem of how to sync your database with blockchain data. And that basically without user interaction. Because we cannot trust the users. We can never trust the users. So first of all, again, as always, some housekeeping. You can follow along on this repository. It's Join Colony Learn-Web3. You can check out all of the latest commits that I'm making and just run your dApp locally if you want to check it out. You can watch all past episodes on YouTube. There's a link here in the repository, so you can check that out. You'll see that there's quite a few already. So I guess we will go all the way to 13 actually. So let's see. It's gonna be quite exciting. The plan for today. So, what is a block ingester? The root of the problem is that the blockchain is naturally async, very much async. It's not like async as in a server is async when it takes a few milliseconds to answer your question. It's async in the sense that some transactions might not ever get included in the block. And then they are just stale and they will never be fulfilled. So that means we have a response time from between a couple of seconds until basically infinity. So that's a very big bandwidth that we have to deal with. So that means we have to kind of persist state in between so that we can come back to a certain action on the blockchain that we can then include into our database. So what does this mean practically for our application? In our application, we have missions. These are stored on the database, and when they are taken by someone, then we add a worker, and when the worker is done, they basically submit it, and then an admin can say, okay, this mission is done. When an admin does that, they send the bounty that was posted with the mission to the recipient, to the worker immediately. When that happens, we would like to change that on the database. We would like to change the state of the mission to, oh, this is done now. But we don't know when that happens. Again, when someone sends off their transaction, it might take seconds. It might take days this is a very bad case, but it might take forever for this transaction to mine. So we have to find a way of keeping track of that transaction, even if the user is already gone offline or something like that. So just imagine someone completes the transaction and then immediately closes their browser window, and within just 1 second or something, and then all of the information is lost. So that means what can we do? Let me explain. Here's the plan. I'm going to just go through the whole workflow in for a mission. This is a very this is the most basic example of something like this, some block ingester as we call it. But you can expand this technique to basically all of your data that you want to, all of the actions that users can take. So the first action is that let me lower the volume a tiny bit. I think it's a bit too loud. Admin. I'm going to start at the beginning. I'm just going through the whole workflow. Admin creates a mission. User applies for mission. Admin accepts application. User works on mission. That's not tracked. That means there's no state change or like increasing like a progress bar or something. We don't have that. User submits. Also not tracked. So the users don't submit data over this platform. They basically submit it via email or Discord or whatever. Admin approves and signs transaction. Signs. Admin approves and signs transaction. Now we get to the interesting part. As soon as transaction is sent off. So as soon as the transaction is submitted, and we're talking like milliseconds to seconds here. It's kind of within the promise of the user interface. So we can basically show a loading spinner or something until what we are doing now is done. So as soon as the transaction is sent off, we get a transaction hash, and that uniquely identifies the transaction. Then store this hash in database. So that means we need, in the mission model in our database, we need a field for the transaction hash. That is then stored. That is basically 0 or null in the beginning, and then as soon as the transaction is sent off, we get the transaction hash. So we can do that because we immediately get a transaction hash back. It's instant. It's even if it's not going through, we have the transaction hash. Then we have a Block Ingestor service. Checks on every block whether there are new transactions that interest us. If there's a new transaction, in our case, that's what's it called? I have to look it up. let's say paid, but it's not paid. It's something else. I look it up. I don't know by heart. If there's any transaction that interests us, so for example, the paid transaction on chain and in a colony that is the one that we're looking for. The ingester, which has access to the database, so that's important. The ingester which has access to the database sets the status of the mission to done, or paid. I think paid is probably the right thing to do here. So there we are. This is the whole workflow. Like 8 and 9, 7, 8, 9 is what we are going to be working on today, because everything else until 6 is already done. So we have to store the hash in the database. We have to write the whole ingester service, which is not much, by the way. It's just a tiny Node script. In our case, we are going to forfeit some of the, I don't know, let's call it measures that would make it stable, more stable, like a production environment. But I'm just explaining the rough concept today. So this is a workflow. So the first thing that we need to do is add the transaction hash field to a mission. And I totally forgot how that works. So we are going to look that up. Prisma. I think we just do the same as before. Yeah, model your data. Okay, let's do that. Here's Prisma. Here's our schema. So here's our mission. So what I think I want to do is, because we have this thing called done, which is kind of ambiguous in our situation. So what does it mean, done? What I'm going to add here is like 2 things that we need. Done in our case meant the worker is done. But what we actually want to do is set a transaction hash when the worker is done, and then have something that is called paid, which is, what's it called? Just Boolean. Yeah, okay, which is Boolean. So I think this is all we need. TX hash is set by the admin, and paid is set by the block ingester. So there we are. Now they say run a migration. Let's do that. Let's run a migration. Let's run a migration here. npx prisma migrate dev. I guess name we call it mission tx hash, maybe. Okay, error. Step 0, edit the campaign to mission table with other default value. How do I do it? How do I do default value? Yeah, there we go. Makes sense. Default false. Yeah. This is relevant when you have already data in the database. Then when you do a migration, they want to know like what should I write in there, because there's already data in the database and I have to put something in there because it's required. So we just make it false, because I mean that's basically a good call anyways. It's a very helpful error message. Let's do this. You're about to drop the column done in the mission table, which still contains 2 non-null values. Yeah, that's fine. We don't care so much. I mean, we are not in a production environment anyways. Okay, cool. And we also have a Prisma client. Nice. So now we have the tx hash column in our database. Now let's do the following. Oh, by the way, forgot to say, while during the last week, I upgraded Colony SDK to the newest version, which I promised I would do. It's a pre-release version, but it should work fine, I hope. So let's see if, I hope that we don't run into any troubles. But yeah, just to give you a heads up, it's basically the same. There's just one minor change that needed to happen. I did it off screen and you shouldn't be bothered by it. Pages. Let's see. It's an API. No, that would be probably here. Yeah, look at that. Yes. So this is where we actually do the transaction. This is Colony SDK doing its job. So Colony extension 1tx pay. We pay a worker and we pay the bounty. So what we need here is to actually have we actually need to, sorry, I'm thinking about something else. We need to have the transaction hash. So how do we get that? That's easy. I think the receipt would be in here. Yeah, it's a contract receipt. So that means we can get the transaction hash from here. So this is actually the only thing that we need. We don't need that. And then console log transaction hash. I'm just going to go to assume that this is probably working because it was working before. So now we need a way to edit a mission. We already have that. Remember, when someone applies for a mission and we accept their application as admin, then we have an endpoint for that to edit a mission in our API. And it's kind of the same. I think we can reuse that endpoint, to be honest. That would happen here, basically. So let's finish this off real quick. Actually, no, just let's go to the endpoint in the API and see what we actually need to do there. So we have mission ID, and I think, yeah, look there, we have it. Let's put yes, perfect. So we need to extend this a little bit, because right now the only thing that it can do is change the worker. When we accept an application, then it changes the worker. So what we want to extend it to, that it also can take a transaction hash. So let's make a type here. Edit data, and that would be worker, and that is optional, which is a string, and the tx hash, which is also a string. And data here is edit data. Yes, data workers undefined. Okay, so let's make it simple here. We have all kinds of guards in place already. So we were asking whether a user is admin, and so on and so on. Now we can say, let's see what happens. There's only two things that can happen. In a real application, you would do that a little bit more involved. You would probably also have some kind of validation library in there that just does this job for you. But for now, for our case, this is just exactly what we need. We can just put a simple guard in here. So if data worker, we do this, right? And else if data.tx hash, we do something else. Update where mission ID, and then data tx hash, data tx hash. What? It might be that it's not really updated yet. The Prisma client. Here's tx hash, it's already in there. Ah, okay. Yeah, we went there. Now it's happy again. So if there's a worker, we update the worker, and if there's a text hash, we update the text hash. It's as simple as that. There's both, then we update the worker. I don't know why someone would send both. I think these kinds of cases should not bother us too much, because I want to get to the gist of it. And for this, again, you would probably have some sort of validation library that extracts the actual intention and gives some proper errors, if there are any. I think this is like, we can just remove this. I just don't like when it's red. Okay. So we can actually now update the TX hash with the same API endpoint. Then we can now go to our missions ID application. I think this is where it's at. Yeah, there we go. Accept application. This is our this is the function that we need to call, or that we need to copy. Application, no, let me see, missions index. No, sorry. ID index, this is where we are. So pay, let me paste that in here. And we have that. Right, so we do this. We make a put request to the mission ID to the API endpoint that we just edited. And what we want to do is here we want to put in TX hash and transaction hash. Right. Let's make this a little prettier. Cool. So we're storing the transaction hash on the database. What I want to do is I want to see if this actually works. Yes. I want to see if this works. And we can click through our beautiful app again. So we log in. Do we have MetaMask is connected? Connect, login. Don't know if we're okay. All missions. Foo. There we go. Pay worker and complete mission. So we can still do that. I'm not sure. Well, let's see what happens. Version 12 of the current contract is not supported in SDK as of now. That is something I did not expect. So as I said, I messed with the SDK. Well, we found an issue. Why would that be? I don't know. I guess we have to fix it live. It is how it is. This is what it is. I will remove that from the YouTube version, so you don't have to watch that. But here we go. does this it's going. Okay. Yeah, to the YouTube person, I will see you on the other side. And we're back. Magic. Let's go to the home page again. Sorry, log in again. We need to connect. I don't know if we have to log in. No. So, okay, this is where we were before. Oh, one more thing, actually. Let's fix that first, because our UI still depends on this done tag that we have. Let's actually, so that what we did, the migration basically reset all of our existing missions to they are not done. But what we want to have is yeah, okay, he's still the mission worker. That's fine. Yes, and what we want to do here is also make sure that the mission doesn't have a TX hash, right? So otherwise, if there's a TX hash, we don't want to show the button. Yes, that is that. So and I think that in the mission itself, column missions, mission list item. Yes, look at that. TX hash. That's what we need. And then we probably want to have yeah, that's fine for now. We can add a different style. Let's say we can have a style called paid when the mission paid is true, right? That's what the ingester does. Right now we don't have a paid style. Let's actually add one so that we can see later. Color green. Let's make it very beautiful. Okay, so now we can pay someone. That's what we wanted to do before, and see if it works. If it actually sets RTX hash. Let's go to missions. To the mission with the ID. This is where we are. Yes, so there is the mission TX hash. That means when we go back into this view, we will see that the button is hopefully gone. So let's do the pay worker. Okay, we have a transaction to sign. Let's do that. Let's see what happens. Well, we don't see anything because I don't think that we are logging anything. Here's our put. But we would be, if there was logging in the network, we would be able to see. Here's our put request. So request payload, this is the TX hash. So that worked. We actually got a TX hash and we sent it to the server, to our endpoint. So okay. Version 12 of the connection is not followed. Beautiful. Why is this happening? Because I think we need to restart the server. Because we installed the version of Colony SDK while the server was running. SDK add quick fix save. npm run dev. Let's hope it works now. Let's log in again. Blah, blah, blah. Connect, login. I think we don't need to log in actually. We were already, I'm not sure. All missions, foo. Okay, let's clear that out. Let's do pay worker. MetaMask opens, confirm. We have one response. Okay, true. Okay, so this worked this time. That means this button shouldn't show anymore. That means the transaction hash is now in the database. Let's see if that's true. Okay. Button is gone. Sorry. We always have to connect again. That's really annoying. Let's go back. Bar. Oh yeah, because we still have a worker. We cannot. We still don't have a worker, so we cannot pay this out. So if we go to foo, we are actually logged in and we have a worker here. Actually, we can just in this view, we can just make another field that says done. I think this is probably very appropriate. Let's do that. That is this one. Ba, 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 da, da, dum. Ba, 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 da, dum. let's put it here. Mission dot paid p. Let's make it bold. This mission was paid out. Paid. Oh, yes, paid, right. Right. So what I did now is that paid, and this is actually set by the ingester. So we don't have paid yet, so that makes sense. What we actually want to do is mission, if it's not paid and the mission has a TX hash, that means it's still pending. Then we can say payment for this mission is still pending. And that's what we actually should see now. Ah, there we go. Payment for this mission is still pending. Very cool. So that means this transaction has now in the database. Now we can finally start with the block ingester. So the block ingester is going to be a little node program that runs alongside the actual web application. It doesn't need to be inside the web application. It can just run by its own. This is actually what we do for our dApp as well. Because it doesn't need really a web interface or anything. It just, what it needs is access to blockchain and access to the database. So it can kind of sync the two up, or kind of pull data from the blockchain and put it into the database. This is actually what it does. But it doesn't need a web interface. It doesn't need to know about our app in the slightest. So we just are going to run it alongside it. Yeah, there we go. Let's make a new directory here and call it ingester. And make a little file called index.ts. In this file, because it's a different program, we need to import colony SDK again. And we also need to set up Prisma. Let me quickly look at how we did that. It's probably here. I mean, we could probably get away with some code sharing. I think it won't hurt, to be honest. I think we can do that. Import Prisma from Prisma. And let me just, I want to do here is just make sure that that this works. We can actually also co-share the Colony SDK from the server here. So let's make sure that Prisma works first. I forgot how to do things. Look, we could do this, for example. We could have a const testing equals async, and then we paste that in, and here we can just do that. Find first. Let's just do that. And then console.log this mission. And then we just run testing and see if this is actually... I'm always making semicolons, I'm sorry about that, but we have to keep a style, I guess. So we are going to use a little program called TS Node to run this, because I want to write this in TypeScript. Because it's going to be immensely helpful with all of the SDK stuff and the mission stuff, the Prisma stuff. So let's see if we already have it for some reason. So if we do node modules bin, we don't have it. Okay, let's install it. npm install ts node save dev. There we go. And now I can do npx ts node source ingestor index ts. Well, that's interesting. I think this is because yeah, it's module ES next. Well, I guess we probably need a different TS config for that. I'm not really sure, to be honest. Ah, that's annoying. This is this annoying tooling stuff. Let me see if we can specify a config file. We cannot. That is interesting. That's not very helpful. What is a TypeScript JSON project file? Maybe that's what we actually want. Let's see, what if we let's just use the one from Colony SDK, tsconfig JSON. Okay, there we go. Okay, then let's just use that one. Copy the Colony SDK tsconfig JSON to let's call it tsconfig.ingestor.json. And then we can do npx ts node-p tsconfig ingestor.json source ingestor index.ts. There we go. So we have access to Prisma in our little context here. Cool. Let's also import from Colony. What can we import? Let's go there first. Let's see. Up. I think I actually want the client. I want access to the client, to the Colony network. Client as Colony network. Actually, let's rename it here. I think it's a little bit more clear what's happening. Colony network. Client is just a stupid name for this. Okay. And we can also do the same thing again. We can say const meta colony, for example, equals colony await colony network get meta colony, and then const funding equals meta colony dot which one is it? Get balance. Wait. And then console.log. And then we need a function from colony SDK, import, which is called toEth, so that we can see, and then toEth funding. Because the funding is going to be in way, it's going to be a very big number, so what we want is the actual funding. And that's the funding in native token from this colony. So let's execute that. There should be some stuff happening here. Yeah, there we go. That seems fair. It seems fine. Okay, so that was my main concern. We have access to Colony SDK now. We have access to Prisma, and that's all we need in our little ingester. So what we can do now is we actually need another function from Colony SDK, which is the colony event manager. And we are going to set up a new one, const event manager equals new colony event manager, and we need a provider. I think I can probably just reuse the one that we have in here as well. Let's just export this one. And let's get it in here. Provider. Right? Remove semicolon. And what we can do now is we can basically set it up so that it does something on every block. You can specify your own times and your own kind of, I don't know, block times that you want to check. But the simplest way to do it would be to say provider on, and then there's block. So provider on block, and then we can say console.log. I'm not sure what is in here. Just let's log whatever this is. Don't worry, we are going to use the event manager soon, but for now we just listen on block and see whether we get a block every, I don't know, it should be every 5 seconds. So let's see if that happens. It's kind of the first thing that we do. Yeah, we wait for a new block to be mined. That's the provider can tell us that, and then we can just react to that. We can just basically say, okay, what do we want to do now? Because then it means, oh, there's something new on chain. Let's interact with that. So maybe there's some new information. Maybe there's some events that we care about in this new block. So that's what we're going to do now. We just run our ingester again, and yes. So apparently this is the block number, right? So every block we get the new block number, and you can see that it's roughly, it should be every 5 seconds. Cool. So we can do something on every block now. So how does it work with the event manager? So the colony event manager helps you to kind of interact with events that happen on colonies. To listen to colony events, we need to install another package, which is adequately called colony events. So we just do that, npm install add colony/events. Save. And then we can use that. Well, sorry. We can use it here. Import from colony events, and that is one TX payment events factory as one TX payment events. So yeah, don't worry about this weird name. This is an auto-generated file. We just rename it in our case here. I'm just too lazy to rename that every time something new happens, so we just do that here. So now we can set up something that kind of tracks our events, and we can set up a filter that's basically saying, oh, there's new block events in this block. Let's give me all of the events that are filtered by this criteria. So the criteria are manifold. But what we want to do is we want to listen to a very specific event that sits on the one TX payments events thingy. Let's see what we have available. I told you earlier that I was gonna look it up, but I didn't. So we have to see. It's in here. We see. We can say one TX event source. So the one TX contract here is the one that emits the event that we care about here, which is the paid event. I still don't know how it's really called, but we will learn it soon enough. And then the event manager can basically give us a create event source, and it can do that from the one TX payment events. And then we can say const paid filter equals event manager create filter, and we give it our 1tx event source, and now we can see. So what do we have? We have logs at owner, logs at authority, 1tx payment made. That looks like the event that I care about. Let's see if that works. So we have the paid filter here. And now on every block, our event manager has a nifty function that can say get events, and then we pass in a filter, which is the paid filter. So there's a bunch of setup here. Depending on how many contracts you want to watch, that kind of gets a bit bigger, but this is very abstracted. This is already quite simple to as opposed to what you would usually do here. And then paid events, and this is async, so we have to make that async as well. So that's basically it. Let's, on every log, let's just get the events and log the paid events. I'm not really, I think this is actually giving us an empty array if there are no events. So what I can do, because right now, this will listen to all of the paid events in all of the colonies. Which is quite a bit. So what I want to know is, let's see if that works. I mean, this is what the ingester needs to do, right? It cannot know, hey, I mean, it could. We could also say, okay, that would be a bit more involved, right? So we could say, okay, which colonies actually have missions, and then only set it up so that it listens to missions on these colonies. That's also something that is possible. But let's keep it simple in our case. And because otherwise we have to switch it around dynamically. And let's just hope that there's not too many events going on. To actually show what's happening. Let's start this. Huh. Well, that is not something that I expected. I tested it earlier and it did work. So it doesn't like the get events. Do we know why? Well, it seems I have to bulletproof this a bit more. I just basically worked on it today. I tested it, so I thought it would work, but it doesn't for some reason. What is the error? Maximum call stack size. That's not very helpful. Not at all. You know what? Maybe we can be smarter about this. I have to fix this. What if we do it in a bit of a different way? Because we know the transaction number. So maybe we don't have to do something on every block. I wanted to showcase this. I wanted to showcase that this works. But for some reason it doesn't. I'm not sure at all what is going on here. Let me maybe just log the filter that is being created. So this is event source. There is topics. So this is basically the magic sauce. Topics is what our event source is creating. And I wonder why this is a problem. Well, I don't want to fix it here. So my second approach here would be to do like a timer thing, like a scheduler. And that's probably even the smarter thing to do. But I wanted to showcase our the event library here, which apparently was a bit of a failure, but I will fix that for sure. The other option is that we just have a scheduler that runs every, I don't know, let's say minute, or like let it be even 5 seconds or whatever. And then it checks for all of the missions that have transaction hashes but are not paid. And then it takes these transaction hashes, gets the transaction for these hashes, and then extracts the actual data out of there that we need. Let me see how this could work. I would like to go to the Colony SDK because I know that I have I'm doing this already. Send meta transaction. Yeah, I think that might be in here. Structure, broadcast meta transaction. Yes. So this is a bit weird. This is something that Colony SDK does internally, but this is how you could parse all the events that you care about from a transaction hash. So the first thing would be let's make it relatively stupid for now. Let's do a set interval. Every 5 seconds. And in that interval, we do the following. Const mission and we can also just do find first, because then in 5 seconds it's just going to do it again. This is not very performant, but we don't need to be performant here in our little find first. And then we can say where tx hash. I wonder if they have something that is not null or something. I mean, that is definitely needed. Freshman client API. I think Google will find that for me quicker. Can we do that? Can we just do that? Interesting. Okay. Where not tx hash. Let's try null as opposed to undefined, as it says it here. This is async. Where and paid is false. And then we just console.log the mission for now. Let's see what happens. Okay, there we go. I mean, that seems to have worked. At least there's a text hash and it's not paid. Cool. Then what we want to do is, I think there is a way to provider get transaction receipt for a transaction hash. Yeah, I know TypeScript. We know it exists here because it's not null. That's why, wait a second. If mission, so if there's no mission, we just return. And tx hash as string. just cast it as a string. We know that it exists. Or we can also just check. That's fine. We can also just check. We can also just put a guard here. Or mission tx hash. If there's no tx hash, we also just return. It's fine. So const receipt equals console log receipt dot logs. So this is the stuff I was talking about earlier in Colony.js, Colony SDK. We can actually parse logs here. Okay, let me explain how this works. When we get a transaction receipt, we can get the logs from the receipt. The logs usually could contain multiple entries. That means, for example, in this transaction, multiple events happened. And this is probably even the case in our case as well. So multiple events happen, and that means we have multiple entries for our logs. When we try to decode them, when we try to decode the logs, because they are going to be like this, they're going to be gibberish in when we just look at them. But our contract interface can actually decode them. So when we try to do that, it will throw an error if it doesn't match, if the log doesn't match to our contract interface. And this might as well be the case, because the interface, the events can also come from different contracts, from different contract interfaces. So we only have one contract and that we care about, and only one event that we care about. So what this does here is it basically tries to parse it. If it doesn't work, it just catches the error and returns null. And this is exactly the same thing that we are going to do now. I mean, we are going to be doing it a little bit differently, but we definitely are going through all the logs. So we can say receipt logs we can say here, you can say found event, let found event equals null for now. Receipt logs for each log. Then what we are going to do, we try to found event equals, and then we use our event source, the 1tx event source interface, parse log, and we put in the log. So this is a bit more complicated than I was anticipating, and I will make it easier for Colony SDK. Let me actually write that down, to have a function that can do this for you as well. Expose parse log function. Okay, so what we didn't do here is we have to kind of try catch this. Nothing. And well, then we can say if found event, then we can do something with it. And the found event here has is going to tell us, well, that the event was found, and that's actually all that we need to know. That's all that we need. There's more information on there, but it's all that we need to know that the event happened. That means the payout did happen, and we can actually set our we can set then our paid flag to true. So this is not terrible. I wanted for it to be better, but it's also not terrible. I think, again, this is probably even the better method, because we just go through our database. We don't have to look at blocks and everything. We just go through our database and check regularly whether we find something that is not really finished, and then we can just handle it. Then we can just handle it like this. If found event, we just console log it. We have another one here. We don't need the filter anymore. We definitely don't need to call a network. We definitely don't need to ETH anymore. Okay. Let's start this. Let's start our little block ingester. Okay. Let's cancel it, because otherwise in 5 seconds it just comes again. So here you can say our beautiful log, and this is already parsed. So we can see that we have a lot of information in here. And that is for the payment that we made earlier. Then we can see like the agent. I think this is the person who initiated the payment. And we have the number of payments that were made. As we can see here, it's 1. So yeah, this is a very helpful little piece of information, but we don't really care so much about the contents of this, because we know everything that we need to know here. So if found event, then we can actually say await Prisma mission update. Where ID, I think, is a mission.id. What are you telling me? Oh, oh yeah, data's missing. Sorry, that's all. I mean, yeah, fine. Data paid true. This is all we need. This is all we need to do. This is really all there is to it. Kind of happy that we did a little detour there. It made me aware of this problem that we saw, that I still have no idea what it is, but I shall fix that. Okay, so this looks fun, right? This looks proper. So every 5 seconds we do this. We can maybe do like a little log. We can say console log found pending transaction, and then we can say mission.tx hash, And then we can say handling it. To show confidence, you know, it's handling it. It's doing it. And let's see. So if we are, if the code is right, it should do it once. I think maybe twice, because maybe we have 2 transaction hashes in there, but I think only once, to be honest. Okay, found a pending transaction, handling it. I hope that it doesn't come again, because it really shouldn't. We need to wait 5 seconds. So I think we can safely say this is handled. And let's, I think, poke around in our little app and see what we can break. So we go back to our missions. We go to bar. We still have an applicant. I think we are admin. So we can accept this. It probably is accepted. Would be nice to have some feedback here, right? But that's just a matter of React state. I don't have to tell you how to do that. Let's go back and oh, look at that. We have a worker. And now we can say pay worker and complete mission. Actually, let's check our full mission before. And we can say this mission was paid out because our ingester did the right thing. So let's go to bar and actually pay the worker. And that gives us MetaMask. And we have to confirm here. And at some point now, our ingester should pick it up and basically say, hey, there was something that happened. Let's check. Well, maybe not. Oh yeah, there it is. So found a pending transaction, handling it. And let's go back in and see this mission was paid out. So our ingester was doing a wonderful job at doing this. So this is the rough concept of how this would work. If you want to have like a production-ready ingester, this would be much more complicated because you have to put in a lot of safety measures that this thing doesn't crash, and if it crashes, it has to restart. And you have to just prevent a lot of stuff that can happen, like memory running out, or some things like that. But roughly, this is the idea. This is all there is to it. If you want to have something that is kind of syncing up the blockchain state, you would do it like this. So you can either, you can either do this. One way to do it is what we're doing here to save the transaction hash. What you also can do is like what we tried to do before. For that, you don't even need transaction hashes. You can basically just say, technically, you could just identify the entity in your database just by looking at the block state, if that's properly set up for you. If you cannot identify it, if you cannot like do this kind of one-on-one mapping, then transaction hash is always a good way to go because you always get it, you always have it, you can always identify stuff with that. Yeah, that's it. We're under 2 hours. That's amazing. I hope you had fun. We wrote a little ingester. We ran into some problems. Yeah, I hope this was cool. And let me know if you have any questions, like in the comments or anywhere else. And have a wonderful time of day. Bye bye.